Hey everybody, it's Mr. N here, and we've got another lesson. This one is on midpoints and distance. And so let's take a look, starting with our notes here, at the basics of what we're going to be talking about. But before we do that, we have to identify a few things, which you probably already know right now, but let's just talk about it anyway. As for the coordinate plane, right here, I'll use my little lightsaber. And, let's do a different color this time. Let's do a green one. So, review the coordinate plane, and we've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we draw our plane, and then we say that we have our quadrants, but notice that we went around in a counterclockwise direction. So we went counterclockwise, and this is the positive direction in mathematics. So in mathematics, we'll always go counterclockwise. We'll put our origin here at 0, 0. And one of the reasons we go counterclockwise is, if you take a look at things around us, the Earth rotates in a counterclockwise direction. Our solar system goes in a counterclockwise direction. Our universe rotates in a counterclockwise direction. But then I can confuse you with all this and tell you that all of it is arbitrary anyway, because we really don't know what up or down is in the universe, because we could technically be upside down. Everything's based on our vantage point. But regardless, we're going to go with the counterclockwise direction as positive in math. And then you may be wondering about sundials, and why are those? Well, remember, if we're going in a counterclockwise direction, when we first talked about time and everything, sundials showed us the shadow, and those went in the opposite direction, which would have been clockwise. That's why we have a clockwise direction like that. But just remember, and we're going to recall here what our quadrants are. So we've got quadrant 1 right here, quadrant 2, quadrant 3, and quadrant 4. Okay, now knowing that, I could place points in there and find distances. So if I place a point, say, in the quadrant right here, I can count how far out I went this way. Say we went 1, 2, 3, 4, 5, 6, and suppose we went up 1, 2, 3. Okay, so suppose we did that. This had a distance of 6, that had a distance of 3. We can actually find what this distance would be in here from this specific point to that point. We could just use the Pythagorean theorem. So that would be 6 squared plus the 3 squared, and then I would take the square root of that, and that would be this distance, because it's like saying a squared plus b squared is c squared. Now, using that, suppose I generalize this, and I say I have a point right here, and I'm going to call this point x1, y1. So let's go ahead and I'm going to highlight this for you guys that I called this point x1, y1. And then I'm going to put another point up here. And this point right here, I'm going to call this x2, oops, I'll use the highlighter, x2, y2. Well, I can find this distance in here, and maybe you've covered this distance formula before by just simply using the Pythagorean theorem. Well, that's going to be a, this is going to be b, and we know that a squared plus b squared will give us c squared, which will be this distance. Okay, so how do I get a? Well, I can get a by subtracting the right point minus the left point. Well, if this point is x1, y1, then this point over here would be x2. That's a different x because I moved along the x, but it's the same exact y value, y1. And then we have our other point up there. So then I can go through and do this and solve for a, and that distance will be x2 minus x1. Doing that same thing, this distance for b will be y2 minus y1. And now I just plug this into my Pythagorean theorem for a, for b, so I'll get x2 minus x1 squared plus y2 minus y1 squared is going to give me the c squared, which I called d over here, which is my distance. Take the square root, and you end up with the distance formula. So that's how we get the distance formula, and you guys are just supposed to at this point, I want you to memorize the distance formula. So it's going to be the square root of x2 minus x1, that quantity squared, plus y2 minus y1, that quantity squared. So that's how we can find the distance between the 2 points. Now, for us to find something called the midpoint is in the middle. Well, how am I going to find something that's in the middle? Well, same situation. If I have x1, y1, and I've got another point up here, which this is, we'll call this point Q, and we'll call this x2, y2. Well, I need half this x length, half this y length. That doesn't look so good. That doesn't look like half, but it is. And in order for me to get where this half is, and this half right here, I would have to find the average of that full x1 to x2. So I'm going to say x1 plus x2 divided by 2. In other words, what I'm saying is, how do you find the average of two numbers? You add them up and divide by 2. That's what I'm doing. I'm finding the average of these two numbers and the average of the two y numbers. So that will give me the midpoint. And that is my midpoint formula. x1 plus x2 over 2, y1 plus y2 over 2. Next, we have something called a segment bisector. A segment bisector is a point, ray, line segment, or plane that intersects a segment at its midpoint. So anything that's going to cut this right through here, which is the midpoint. It could be a line, it could be a ray, it could be a line segment, and what will end up happening is the distance from A to that midpoint will be the same distance as B to that midpoint. So if CD, line CD, is a segment bisector of segment AB, then A to M will be congruent to M to B, and you could say AM is equal to MB. Now you're wondering here, what is this congruence? What is this equal? Congruence is more like a generality. So when I'm not going to put in numbers, I will just say segment AM is congruent to segment MB, and then AM equaling MB. That means I'm about to put numbers in. I'm about to say something more specific. So that's pretty much it for this section. Let's see if I'm going to do a couple examples for you today with these. We are going to do the student journal ones in class, but let me do a couple of these additional examples right now. So I'm going to go ahead and enlarge this, and let's take a look. Find the midpoint between these two values. So let's go ahead and do that. We're going to label this x1, y1, x2, y2, and then to get the midpoint, this is going to be the average of the x's and then the average of the y's. So this becomes 4 over 2, which is 2, and this is 7 over 2. Now, let's do these. Find the distance between these two numbers. Again, I like to, and part of why I do this is because I had a teacher in high school who always forced us to label everything x1, y1 like that, x2, y2, and then we don't get it confused. And so we know that the distance formula is going to be the square root of x2 minus x1 squared, y2 minus y1 quantity squared. So let's go ahead and put that in our distance formula, and I will get 1 minus 4 squared plus negative 1 minus 2 squared. Cleaning this up, I will get, this becomes negative 3 squared, which is 9, and this also becomes negative 3 squared, which is 9, which is the square root of 18, and I'm going to reduce this for you. That's 9 times 2, so this becomes 3 root 2 as my distance. Let's go ahead and work out this next one. And on this next one, same thing, distance formula, and we're going to say x1, y1, x2, y2, and this becomes negative 1 minus 7, minus negative 7, let's clear that up, squared, plus this becomes 6 minus negative 2, quantity squared. So the distance becomes, and this is minus a negative, so this will become negative 1 plus 7, which is 6 squared. And this one becomes 8 squared. So the distance becomes the square root of 36 plus 64. Adding these up, we get the square root of 100, which is a distance of 10. All right, so in class, we'll go ahead and do those other student journal examples. Hopefully this lesson wasn't too bad, and hopefully you understand midpoints and distance. So thanks for watching. Make sure you hit that subscribe button, and you get all the notifications when all the other videos are uploaded. All right, we'll see you guys in the next video.